Today we are going to be discussing a new concept dealing with the solution stuff that we talked about yesterday. We're going to be talking about concentration. Concentration. So we got to concentrate by staring and paying attention. Concentrate. Concentration is a very easy concept. And we're going to go over it somewhat quickly. You're going to have some practice, but concentration is not really that hard. It is simply a measure of the amount of solute dissolved in a given amount of solvent. So that is what concentration is. A measure of the amount of solute dissolved in a given amount of solvent. Remember, solute is the stuff that is getting dissolved. Solvent is the thing doing the dissolving. Typically, we're going to be dealing with a solid dissolved in a liquid, but that's not always the case. But concentration is how we measure how much we have dissolved. So if you've ever looked at like your juice containers and you see that it says from concentrate, well, what they do is they take the juice, they get all the water out of it, they concentrate it down to where you have a whole lot of solute dissolved in a very little amount of solvent. That's the concentrate. It's a very high concentration. And then when you take that from that little can of frozen juice and you put it in your pitcher and you add water to it, are you changing the amount of solute there? No, because you're not adding orange juice solute. You're not changing the amount of solute. You are simply changing the amount of solvent. So now you suddenly have the same amount of solute in more solvent, and so it is less concentrated. All right? There are lots of different ways of measuring concentration and lots of different ways of talking about concentration, but for this class we are only going to focus on one of them. And it is the one that is used the most frequently. It is the most common one, which is why it's the one we're going to talk about, and it is molarity. Molarity. It's a fun word to say, molarity. All right, so we have molarity, and we signify molarity with a capital M. Not a lowercase m, it is a capital M. Molarity is simply the number of moles of solute in a liter of solution. Number of moles of solute in a liter of solution. So it's moles per liter. Okay? That was what in your lab yesterday that the little concentration meter measured. If you looked at the units, it was moles per liter because you're measuring the molarity. Okay? So, moles per liter. The important thing here is that you recognize this right here. It is liters. So the volume of your solution has to be measured in liters for molarity. If it's measured in some other unit, you have to convert it to liters in order to do molarity. It has to be moles and it has to be liters. Okay? So if you will look at your pink sheet, on the back, there's a little section that says solutions, and you will notice that there is an equation for molarity, and you see that molarity equals moles per volume. Okay? Where the moles is measured in moles and the volume is measured in liters. Now, specifically, this is moles of solute and volume of solution. So it's the whole thing. So this is the equation for molarity. This is a very simple equation. Not very hard to do. You have three variables, and there's a division involved. So there's going to be a little bit of algebra manipulation involved in this, but it's really not complicated at all, assuming you actually pay attention to what your units are. So as long as you're paying attention to the units, these calculations are pretty simple, pretty easy to do. So I'm going to pass out a worksheet to you, and I'm going to do a couple of examples off of that worksheet, and then you're going to have time to practice on your own. All right, if you'll look at the worksheet, though, we are going to do number one, and this equation right here is rather important that you remember. Molarity is moles divided by volume, so that's pretty important there for this. So look at number one. What is the molarity? So what is the molarity of a bleach solution containing 9.5 grams of NaOCl? So you'll notice that I used a little m here. Little m is for mass. Big M is for molarity. Okay? So we need to make sure that you don't get that confused. All right? Because it gave me 9.5 grams of NaOCl. I want the molarity per liter of bleach. So my volume is 1 liter. Now, what is my equation for molarity? Moles over volume. So, I don't know moles, do I? So, I can't do this equation. I can't solve for molarity until I know moles. But I do know my mass. So, what am I going to have to do? I'm going to have to do a mole conversion. So, let's do that. If I want to know my moles, I take my 9.5 grams of NaOCl, and I have to convert to moles. So if I have grams of NaOCl here, what goes down here? Grams of NaOCl. So I'm going to put grams of NaOCl there. And what's going to go up here on top? 1 mole of NaOCl. Okay? How many grams? Well, I need to figure out the molar mass of NaOCl. So I take the mass of sodium, which is 22.99. I add the mass of oxygen, which is 15.999. I add the mass of chlorine, which is 35.453. And would somebody please add all those together for me? 74.442. Okay? So now, my grams of NaOCl will cancel out because I've got grams on top and grams on bottom. I'm left with moles of NaOCl, which is what I want. So now I'm going to simply take my 9.5, multiply by 1, divide by 74.442, or essentially divide 9.5 by 74.442, and I get that my moles are what? 0.1 what? 27 moles of NaOCl. So now I know my number of moles. My number of moles is known to me. So if I look back at my equation, my molarity is moles divided by volume. Well, what's my volume? My volume is 1 liter. So that means my molarity is going to be my number of moles, 0.127 moles, divided by 1 liter. What is 0.127 divided by 1? 0.127. All right, I'm glad you guys can do that one. What's my unit going to be? Moles per liter. So my molarity is 0.127 moles per liter, which has a special name. We call it molar. This happens to be one of the very few things that we have in chemistry where the symbol that we use to represent something and the letter that we use for its unit happen to be the same thing. But if you see a number that says a number with a capital M, that's molar. So this is 0.127 molar. Okay? Everybody with me? Okay. So let's do another example. A liter of 2 molar NaOH. What did I just tell you? I told you the molarity was 2 molar. What else? You know that the volume is 1 liter. Contains how many grams? So mass is what I'm looking for. So I also need to know the number of moles. So what's my equation? Molarity equals moles over volume. So what do I want? I want grams. In order to get grams, I have to know moles first, right? So I need to solve this equation for moles. When you solve an equation, it means you need to get what you're looking for by itself. So I need to have moles by itself. So I need to move my volume. How do I move my volume? Multiply by V. All right? Because in order to move something, you have to do the opposite. If it's being divided, I multiply. Okay, so I'm going to multiply by V, and that causes my V's to cancel out. But whatever I do to one side, I have to do to the other side. So that gives me the volume times my molarity equals my number of moles. Okay? Cool? Yay? So what's my volume? 1 liter. What's my molarity? 2 molar. And that's going to equal my moles. Okay? So, that means I have 2 moles. Because 2 times 2, 2 times 1 is 2. Now, am I done with the problem? No. What do I need to do? Grams. I need to convert it to grams. So, I have 2 moles of sodium hydroxide. So if I have moles of sodium hydroxide on the top, what goes on the bottom? Moles of sodium hydroxide. And how many? 1. And what's going to go on top? Grams of sodium hydroxide. And how many grams? Well, sodium is what? 22.99. Oxygen is 15.999. Hydrogen is 1.008. When I add all those together, I get 39.99 something. 7? Yeah. 39.997. So this has my moles will cancel, left with grams, which is what I want. So now I do 2 times 39.999, and I get that my mass is 79.994 grams of NaOH. Okay? Cool? Yay? Any questions? Now, what if I want to change my concentration? What if I have a certain concentration, but I need a different concentration, what would I do? What do you think? Anybody? Add what? I could either add more solute or add more solvent. Okay? Typically, when we're dealing with needing to get a certain concentration, it's because we have a certain concentration that we buy from the chemical company, and we need to use a different concentration in our experiment. Because you very, very, very rarely will you need to use the stock concentration that comes from the chemical company. Very rarely will you need to use that when you're doing an experiment. You usually need less concentrated stuff for the experiment. So why would they sell it in such high concentrations if you're not going to use high concentrations? Why do you think? Not really. It's not to get you to buy more. But think about it. If I have 12 molar hydrochloric acid, okay, that means I have 12 moles of HCl in 1 liter. So if I buy 1 liter of 12 molar HCl, I have 12 moles of HCl, right? You with me? Well, in most of my experiments, I need 0.3 moles. So instead of buying 1 liter of 0.3 molar stuff, I buy 1 liter of 12 molar stuff, and I can make a whole lot more 0.3 molar stuff than that. Does that make sense? And so that's what we call dilution. We take a highly concentrated stuff and we dilute it to get the right amount of a concentrated stuff. So when we're dealing with dilution, you have to think about the amount that you have, or the concentration that you have, and the concentration that you want. And if you think about it, if you look back at the equation that we just did, or this problem right here, this is kind of the key to it. Because I don't want, that number of moles is going to be the same for each thing. Because if you think about it, if I have a volume times a molarity, that tells me a number of moles, right? Now, if I don't want to change the number of moles of substance that I'm using, I just want to change the concentration, then that means that my initial volume times my initial molarity will equal my final volume times my final molarity. Okay? So, for example, let's say I wanted 0.3 molar HCl, and I wanted 1 liter of it. But I had 1 liter, or say I had 8 liters of 12 molar HCl. Okay? You with me? Well, if I have 12 molar HCl, that's my molarity over here. And let's say I want 1 liter of 0.3 molar. I want to have 1 liter of 0.3 molar HCl. So how much of this do I need to start with? Okay? If I have a 12 molar concentration, and I want to dilute it to 3 molar, and I want to have 1 liter of 3 molar, I need to have a starting value for that. Okay? And that's what this equation is. This is the dilution equation, and that's how this works. So how would I solve for V1 here? Divide by 12 molar on both sides. So the 12 molars cancel out over here. And that's going to give you, well, 1 times 0.3 is just 0.3. So that's going to give you 0.3 divided by 12. What is that? I don't have a calculator up here, so somebody. 0.3 divided by 12. 0.025? What's my unit going to be? Notice the same math you do with the numbers, you do with the units. I multiplied those and then I divided by m. So what happens to the m? The molarities cancel out, so you're left with liter as your unit. So that's in liters. With molarity, your volume has to be in liters. With the dilution equation, the volume doesn't have to be in liters, they just have to be the same. Okay? Whatever volume V1 is in has to be the same as the volume of V2. But it doesn't matter what that volume is. Whether it's liters or milliliters or cubic centimeters. It doesn't really matter how I measure the volume of V1 and how I measure the volume of V2 as long as they're the same. So if I ask you what volume in milliliters, then you can have this one in milliliters and you solve for that one in milliliters. Does that make sense? But the dilution equation, what this is telling me is that I need to start with 0.025 liters or 25 milliliters of my 12 molar concentration. So what I would do is I would actually measure out 0.025 liters of my 12 molar hydrochloric acid. I'd measure that out into a container, and then I would add water until I reached 1 liter of total solution. And then I would have a 0.3 molar concentration. That's how the dilution equation works. Okay? Any questions? All right, you now have the rest of class, which is about 15 minutes or so, to work on that worksheet. Whatever you do not finish in class is homework.